everyone, and today we're going to look at Chapter 7, which is algebraic methods. If you are asked to simplify algebraic fractions using division, we will simplify it by factorizing possible numerator and denominator and then cancel common factors. Let's look at an example in which we have to simplify the fraction 2x squared plus 11x plus 12 divided by x plus 3 times x plus 4. When you think about it, you actually don't need to simplify out the bracket, so the denominator can stay like what it is, and we will try to factorize the numerator, which is the part 1 labeled, and know that AC is 24 and B is 11, so what multiplied by what give us 24 and add to give us 11. So you find it's 3 and 8, so it's 2x squared plus 8x plus 3x plus 12. So you can take 2x out and 3, so you get 2x plus 3 times x plus 4. And you can actually see that x plus 4 can be factorized, as both the denominator and numerator have x plus 4. So you will end up with 2x plus 3 over x plus 3. Now we're going to look at dividing polynomials. A polynomial is a finite expression with positive whole number indices. So basically, the powers have to be positive. If the power is negative, it's not a polynomial. And it cannot be like square root of something or anything like that. You can use long division to divide a polynomial by x plus minus p, where p is a constant. An example of a polynomial is 2xy squared plus 4x minus 5. An example of a number that is not a polynomial is 6x to the power of negative 2. Let's look at an example in which we have to divide f of x by 2x plus 1, and we have to leave our answer in the form f of x equals to 2x plus 1 times ax cubed plus bx squared plus cx plus d. Therefore, we know that we need to divide f of x by 2x plus 1. Since, let's give us an example, like if 6 is divided by 2, it gives 3. So 2 times 3 gives us 6. And we'll start first by division. So we will divide the first term, 2x, from 4x to the power 4. So you know that 2x multiplied by 2x cubed gives us 4x to the power 4. Therefore, you will multiply 2x plus 1 by 2x cubed, so it will give 4x to the power 4. Remember, this is because you're always trying to divide the first term. So 2x multiplied by 2x cubed gives us 4x to the power 4, and 1 times 2x cubed gives us 2x cubed. So you will subtract these two values from 4x to the power 4 plus 0x cubed. You need to remember that when you are doing this kind of division, you should always add the missing term. For example, if we're missing power 3, then we'll add plus 0x to the power 3. And if we're missing, and we know that in this case we're also missing x, so we'll plus 0x, so we will have the term x. Therefore, if we subtract it, we'll get negative 2x cubed minus 17x squared. The minus 17x squared comes from the top, where you will move one term down. Then you will divide 2x from negative 2x cubed, and you get that it's negative x squared, and you would write it on top of the division. And so negative x squared times 2x gives us negative 2x cubed, and negative x squared times 1 is negative x squared. And you subtract this from negative 2x cubed minus 17x squared, and you get it's negative 16x squared. And then you move the 0x term down, and you get you will divide 2x from negative 16x squared, and you get that it's negative 8x, and negative 8x multiplied by 1 is negative 8x, and you will subtract negative x squared minus 8x from negative x squared plus 0x, and you get that it's 8x. Move the 4 down, divide 2x from 8x, you get that it's 4, so write the 4 on top. And at last, you'll divide 2x from 8x, and you get that it's 4, so 4 times 2x is 8x, 4 times 1 is 4, and 8x plus 4 divided by 8x plus 4 give us 0, so the remainder is 0. And we come up with the answer 2x plus 1 multiplied by 2x cubed minus x squared minus 8x plus 4. The next thing that we're going to look at is the factor theorem. The factor theorem is a quick way of finding simple linear factors of a polynomial. The factor theorem states that if f of x is a polynomial, then if f of x equals to 0, then x minus p is a factor of f of x. You need to remember this, and if x minus p is a factor of f of x, then f of x equals to 0. This is just a reverse of the first thing that we mentioned. You can use the factor theorem to quickly factorize a cubic function. First, you substitute values into the function until you find a value of p, so that g of p equals to 0. Then you will divide the function by x minus p, and write g of x equals to x minus p times ax squared plus bx plus c. This is actually a bit similar to the example that we did before. Then you need to factorize the quadratic factor, if possible, to write g of x as a product of 3 linear factors. Let's look at an example in which, given that x plus 1 is a factor of 4x to the power 4 minus 3x squared plus a, and it asks us to find the value of a. So firstly, we're going to write the polynomial as a function. So f of x equals to 4x to the power 4 minus 3x squared plus a. Then, by using a statement from the factor theorem that we looked at first, which is x minus p is a factor of f of x, so f of p equals to 0. So p equals to negative 1 in this case. And we'll let it to equal to 0, and so we get that 4 minus 3 plus a equals to 0, and so a equals to negative 1. And let's look at a proof to this theorem. In order to prove that x minus p is a factor of f of x, and so f of p equals to 0, so we will look we know that g of x is a polynomial expression, and we know that x minus p is a factor of f of x. Therefore, f of x would equal to x minus p multiplied by g of x. Therefore, we're trying to prove that f of p equals to 0, and so we will write that f of p equals to p minus p multiplied by g of p. And you know that we're going to substitute the value of x into p, so p minus p equals to 0, and 0 times g of p is 0. Therefore, f of p equals to 0. And the proof is done. And that's the end of this chapter.